welcome to Mini Tutorials in Spectroscopy. Let's talk about normal mode symmetry. For some relatively simple molecules, we can easily determine normal mode symmetry by considering the normal mode displacement vectors. For example, consider the atomic displacement vectors for the new 3 normal mode of water. Since water has C2V symmetry, we must determine how the displacement vectors transform under the E, C2, sigma xz, and sigma yz operations. Here, we see that the displacement vectors are apparently unchanged by E and sigma xz operations, whereas they are reversed by C2 and sigma yz. This defines the character of the new 3 mode under C2V symmetry. We can think about this as if the E and sigma xz operations effectively multiplied our displacement vectors by 1, while the C2 and sigma yz operations resulted in a multiplication of -1. Thus we see that the new 3 mode of water is characterized by the B1 irreducible representation. Let's see if the 1-1-3-1 combination band of water is IR active. First, recall that the v equals 0 wave function transforms as the totally symmetric irrep, which is A1 under the C2V symmetry. For the 1-1-3-1 combination level, there is 1 quantum of nu 1 vibration and 1 quantum of nu 3 vibration. To find the symmetry of the combination level, we must take the direct product of the nu 1 and 3-1 irreps. A transition will be IR active if the transition dipole moment is non-zero. We can see that this will be the case if the integrand transforms as the totally symmetric irreducible representation. We can determine if this is the case by finding the direct product of the v0 wave function, the dipole moment vector component in the x, y, and z directions, and the 1-1-3-1 wave function irreducible representations. Here we see that the x component of the dipole moment leads to a non-zero transition dipole moment. For a shortcut, one can remember that a fundamental transition is IR active if the excited state irreducible representation has an x, y, or z in the translational vector column of the character table. I hope that you found this short video on normal mode symmetry useful. See you next time.